Continue with the next part. So we are seeing the scenario 1. Now scenario 2 is scenario 2. You have an inclined plane and you have a block on that particular plane. So this is to be theta. So in that case, when the weight is acting, it will be always vertically down. Okay, so that is your W. So when this is happening, either you can give a force, and if you're not having any force due to the self-induced weight, the weight will be inducing the motion. So the weight will be divided into two categories. So let me take this in terms of theta. So we are taking reference with perpendicular to the norm, perpendicular to the plane. So in that case, so this will be theta. So dividing this into two components, so this will be W sine theta and this will be W cos theta. So due to that, so in this case the motion will be in this direction, okay, parallel to the plane. So you'll be having motion in this particular direction, and the direction that you are looking at, so you'll be having the coordinates in this particular manner. Okay, so this is X and this is Y. So in that particular perspective, so this motion direction, so you'll be considering this as a plus. So obviously when the motion direction is like this, so you'll be getting a friction force opposite to that. So this is friction force, and you'll be having a normal reaction with perpendicular to the plane. Okay, so in that case the summation of forces which is be acting in that particular blocks are so we need to consider the direction of motion as a positive one. So W sine theta is positive minus FF. Okay, so these are the two things which will be in this particular case. So in this, the FF will be, as usual, it's a product of mu into NR, where NR is also equivalent to, in this case, the NR's opposite value which will be taking, that is only W cos theta. So in this case, that is the opposite effect of where the normal reaction that has been created. So W cos theta is equal to NR. So when you're putting this, so you'll be getting summation of F is equal to W sine theta minus mu into W cos theta. So this is for summation of F for the third, second one. So now the third scenario is we have again the same inclined plane. We have the cube, the block. Now when you are applying a force in this direction, and you are overcoming the gravity and all those things, and you are making a motion in this upward direction. Okay, again here also we will be having W. So in this W, so this is inclined to theta. One second, let me make it clear. So this is going to be theta. So in the normalized way, this is going to be my theta. Okay, so that means we'll be having the W divided into, this is W sine theta, and this will be W cos theta. So the opposite effect of this particular thing will be NR, and since the motion is in this direction, you'll be getting the friction force opposite to this. Okay, so here now since the motion direction in this direction, so you will be having this X in this direction, Y in this direction, so motion is considered always positive. So in that perspective, so summation of F for this particular thing will be F will be positive, so that is the applied force, and W sine theta is against the motion, so minus W sine theta and then minus FF. Okay, so these are the forces which is acting in the X direction, so that is the force which is defining the motion, so we are taking only that particular consideration. So now we need to elaborate the FF. So when you are elaborating the FF, it's going to be mu into NR as usual, so where NR is nothing but mu into, so I'm expanding the NR. So NR is left over with the vertical forces in the downwards direction is W cos theta. So that is the only thing which you have in this particular case. So W cos theta. Okay, so this is thing. So when you are putting in this particular formation, so it will be F minus W sine theta minus mu into W cos theta. Okay, so these are the things which we'll be having in the for a force which is always parallel to the plane. So the next video we'll see when the force is inclined, so how will it be treated. So we'll see it as a case 4 and case 5. Thank you.